Hello, everybody. I thank you for your interest, for being here with us. I have to tell you we are recording this webinar, so if you do not want to be seen, do not share your image. Leave your camera off. You can afterwards, if you have questions, turn on the camera if you want to ask a questions to Alex. If you prefer just to write it, you can also write it in the chat, and we will read it and answer it this way. We'll have time after the presentation for questions, because I think also this is an important topic, and there will be quite a lot of questions because there hasn't been so much information yet about the use of biochar in asphalt, especially not in this case where you not only put it into asphalt as a carbon storage, but also to modify the performance of asphalt. And this is why I'm very happy to have Dr. Alex Let here today with us. We've been in contact for almost a year, and I've been waiting for this webinar for all of this time. Basically, finally we made it. So we are now happy to present him. Alex Let is a specialist in nanotechnology and its application in material construction. So this is a very interesting fact, because we as EBI, we have been working in biochar in asphalt, but as I said, rather as a carbon storage. And now he will tell us how we can modify the qualities of asphalt through the use of biochar and bio-oils. Thank you, Alex. I'll let you present yourself because you know this better than me. Go ahead.
Alex, just a quick comment here from the technical off. I will stop the screen sharing because I learned that your video will not be shown. Wait a second. So now you should be seen by everybody. Okay, go ahead. Go ahead, Alex.
Good morning for people from Europe. Good evening for people from Australia, and good afternoon for everyone the rest of the world. I'm a technical manager of State Asphalt, which is part of the Cypriot group, and I have more than 10 years experience in the construction material regarding the concrete, asphalt, and working with the recycled material, plastic, glass, paper, and biochar. I graduated Polytechnic Institute from Bucharest, Romania, and I did a PhD with the Melbourne University in Australia. And I would like to present my work regarding biochar modified asphalt and green asphalt. But before to start, I will ask you to fill up to answer some question which webinar prepare regarding the presentation.
Yes, those questions you can find in the chat. It's a link to a poll.
So now the question is in the chat.
Yes, and Alex, can you start your screen sharing?
Okay. You can see it?
Not yet.
Now it's okay?
Yes. Great.
As I told before, the title is Biochar Modified Asphalt, Green Asphalt. Traditional way to build a road, the oil it's used in the furnace and by distillation. In the refinery, you get different fraction of the gas and the fuel. On the bottom of the distillation column remain the bitumen, which mixed with aggregates in the plant, you can do the road in the country. The research development of the Cypriot group, our research development lab is in St. Mary's, the new plant of Cypriot group, and is equipped with the latest testing equipment. Our research is focused on increasing the use of recycled material and asphalt mixes. We have a lot of work done with glass, plastic, rubber, and paper. We secure a $3 million research grant with federal government on the plastic research. The biochar used in this presentation, this work, it's coming from Rainbow Bee Eater. And I like to present a few things from their plant. And the biochar is produced by a pyrolyzer of the timber and plastic. I know it's biomass like a general term, but I'm talking timber and plastic because I used in the asphalt so far only biochar from timber and biochar which come from plastic. And they're coming in the absence of the oxygen. It's rich in carbon and stable. It's porous and high moisture content. Fine particles of biochar from Rainbow Bee Eater were chemical treated with phenton ashes, which are bitumen friendly. Chemical treated change the biochar surface, which can be bound to bitumen. To prove the change on the surface of the biochar, we did a FTR of the untreated biochar and treated biochar, and you can see difference between the untreated and the blue one and the treated, which come some peaks around 3,000 wave numbers, which prove some change, which is very, very close with the signal which the bitumen give you in the FTR. In Australia, the bitumen is classified based on the viscosity of 60 degrees, and can be seen it's coming in the different grades: 170, 240, 320, 450, 600. This one is based on the viscosity of 60 degrees, and the soft bitumen is 170 and starting to by oxidation to get the other grade bitumen. What I want to show the viscosity after roll-thin film oven, which the roll-thin film oven is oxidation procedure for the bitumen to identify the properties after the bitumen is used in the asphalt plant. For the 450 best bitumen, you can see here the viscosity after roll-thin film oven is coming between 850 1,300 Pascal or seconds. Why I'm strength this one? Because you can see later on the biochar effect on the bitumen regarding the viscosity after oxidation. Biochar, the viscosity of the bitumen obtained using the biochar can be see starting to increase with the percentage of the biochar. 0% is the soft bitumen which you use for this work, and when you start to increase the biochar in the mix and the soft bitumen, the viscosity at 60 degrees starting to increase. In the end, 25% the biochar and the 170 bitumen, it's equivalent to the 450 binder. The viscosity is 420, 425 Pascal or second at 60 degrees, measured with the capillary tubes. All these samples, it was oxidized with using the roll-thin film oven. Then the viscosity it was again measured, and the change of the viscosity after oxidation can be seen the graph on the right side, where you can see the soft one is the untreated, unmodified bitumen, 170 soft bitumen, which the change in the viscosity is very high, 200, more than 200%. And when you start to increase the binder, the biochar content in the soft bitumen, the viscosity change starting to become more low, which is mean the biochar help to stop the oxidation of the bitumen, which has effect on the improve the life of the asphalt on the street, because stop the oxidation from the sun. Modify the biochar. The chemical treated biochar, it was mixed with the bitumen, and we did a biochar modified bitumen. Then we use aggregates and the biochar modified bitumen in the mixer in the lab to do the asphalt modified biochar. And then we can see here a briquette of the bitumen modified asphalt, for which it was starting to use for testing. We start to do the performance of the biochar asphalt using the well tracking machine and the resilient modulus, and we can see the well tracking machine, which measure the root depth, trying to simulate the wheel on the road at 60 degrees and stay at 60 degrees for 5-6 hours, 1-2 hours for conditioning and 4 hours for testing to measure the 10,000 cycles. You can see when the biochar modified bitumen give you the lowest root depth than 450 and 170 soft bitumen. I use 450 because for testing, because 450 it was the target for biochar with the soft bitumen, and I use 170, which is the soft bitumen, to show from where we start, where you go in the end of the experiment. Resilient modulus, the same. The biochar modified bitumen is very high if you compare with 170 and 450 binder. The biochar modified bitumen is coming around 6,000 Pascal MPa on the testing. What is wrong? Give you the wrong fatigue. The biochar and the asphalt give you low fatigue than the normal bitumen, because increase the strength of the asphalt. You lose some properties in the fatigue and the flexibility of the asphalt. But we are working to improve using the crumb rubber, which the crumb rubber give you some flexibility. But the process is the experiment is underway. The big issue with the biochar and the asphalt, it was the dust, because the biochar, when you using the to pre-blend with the bitumen or to use straighten the asphalt plant like a filler, it's a lot of dust. The next step it was to find a way to fix the dust in the asphalt plant, and we try to do some plastic encapsulated biochar. It means the chemical treated biochar is inside of this plastic pellets. The big issue is this one doesn't allow you to go to use too much biochar in the plastic, because the biochar is very porous and has a lot of moisture. The biochar I use, the moisture, it was something around 27%, and it's very hard in the plastic industry to use the biochar with the plastic, because when you increase the temperature of the extruder to get the pellets, the moisture from the biochar is coming like a steam, and it's hard for the equipment to work. The plastic is recycled plastic, which is suitable to go in the asphalt. The plastic is recycled from the local business, and it's easy to pre-blend and to be used in the bitumen industry. Then we did a well tracking. You can see for the different percentage of the biochar and the same amount of plastic, the root depth starting to go down. Now we have to identify how much effect on the root depth has the plastic, how much is coming from the biochar. It's under working now to identify exactly how much plastic effect is in the root depth and how much is coming from the biochar. The next step, we use the plastic encapsulated biochar like additive to modify the processing oil from biofuel business. In the biofuel business, which some of them using gram rubber, other using the timber, other using the plastic. I'm not expert in this area, but I'm telling you what supplier, advise me. They have a biofuel, some process oil, which is coming like a residue, and the biochar. The biochar encapsulated with the plastic can be used to modify the oil, the processing oil, and make the green bitumen, which doesn't contain traditional bitumen. We prepare a green asphalt briquette using this green bitumen, and the resilient module was around 3000 MPa. We are working on this one to see what is the properties and if the test method we're using now is suitable to characterize the new binder. Because what's happened, the new binder with plastic and biochar, we get a 100 degrees softening point, and it's hard now. Even the viscosity, it was really high, and it's very hard now to see if we are using this type of the bitumen, with this green bitumen, can be characterized with the same testing equipment and testing procedure we're using for the traditional bitumen from oil. And then I want to say thank you to everyone who it was this time on the webinar, but not in the end to say thank you to Cypriot Group and State Asphalt for accepting me to do the job there and to work in the research, because the research involves some expenses, and the Cypriot Group is 100% owned by the family Cypriot, and it's some expenses which we have to cover from production. Thank you, and I'm waiting the questions.
Thanks a lot, Alex. This is highly interesting. So what I've seen is you're actually creating an asphalt with a better performance, but significantly better performance than conventional asphalt, right?
Look, there are some properties is a winner. Some of them like a fatigue, which in this stage it's the loser. I'm trying to find a way to make all of them to be the winners, but will take some time to find the right recipe.
Mm-hmm. Okay, I do not see the chat. I don't know why, but maybe someone could help me. Do you see it? Do you see the questions in the chat?
So I'm speaking from the off. Yes, there were people responding to the chat, and it is in the top line next to the 3 dots.
Yeah, no, it doesn't show. It doesn't show here.
Okay, well, some at least had the chance. I can later on quickly. I think we should start with the discussion, and then later on I will present the result of the chat. Of the questionnaire.
Yeah. But as I said, I do not see the questions that were asked in the chat. Thank you.
Maybe Harald, as in the time in between you're looking for the chat, I asked my question directly to Alex. Thanks for the speech. We have also done this investigation at EBI concerning bitumen or asphalt amended with biochar at only 2%. But
2% related to the asphalt mass, yes?
Yeah, to the final mass, which is I think that is corresponding to your percentage or
yes, 25%. Yes, you are right.
The total applied mass. I just wonder why there was no approach of a very smaller dosage initially, because the changes also at 5%, as I'm not aware whether I took the chart right, but the changes were quite rapidly.
Look, thank you for a question. You're using 2% related to the mass of asphalt. I use 25% related to the mass of bitumen, which is the same. 2% from your side is the same 2% if you make the
same, yeah.
If you calculate to the mass of asphalt. In Australia, we are trying to use less bitumen because the bitumen is more expensive on the asphalt recipe. And the way to use less bitumen, we found the biochar can help to use like a binder, modify, and extender in the asphalt mix. Why are using 5%? Is 5% is very, very small amount, you know, if you look on the reported to the mass of asphalt. But the point is also to use the biochar to modify the bitumen, because the high viscosity bitumen is coming from oxidation. What happened? The 170, the soft bitumen, is oxidized to 600 or 450 Pascal or seconds. But if you're using in the 170 soft bitumen, you're using the biochar in different percentage, you can get any binder grade with no oxidation, only with the biochar.
Okay, thanks for clarifying.
If you have other question, I'm open.
Yeah, I don't know. Maybe you can share this chart again. I'm not sure because I don't have the slide where you presented those advantages in
the viscosity.
Yeah, the viscosity.
Yeah. I mean, the viscosity, of course, changes because it dramatically changes. But there was another one, and it's about the pro and cons, to bring it on the table and to see what can be done. Maybe you think is the particle size an issue, or is the consistency an issue?
Well, I'm using only the fine biochar in bitumen. We can't use the higher particles size of the biochar to modify the bitumen, because it takes too long to have the chemical physical reaction of the bitumen. We're using the very fine particles, and I understood it's more easier to get the fine one if you increase the temperature of oxidation.
Hi, Alex. Can I just put forward the question in regards to bitumen and aggregate adhesion in terms of stripping and particle loss? By particle loss, I mean the test where you make a core sample, you put it in a LA machine, and you measure how much asphalt is lost after the test, before and after compared.
Look, I did the stripping test, which here is named it's a tensile strength ratio, which using the briquettes in the unconditional, the room temperature, and the 3 briquettes in the fridge in the low temperature. Then you put them in the 60 degrees water bath, and all of them is coming around 85-86%, which it meet the specification. Our state it to be higher or equal 80%.
Yeah. Any testing regarding particle loss?
I didn't make the particle loss.
Thank you.
Okay, what I can do now is ask if there are other questions where you want to unmute yourself and ask them directly, because I'm just still not able to see the chat. Or Hans-Jörg, maybe if you could read.
Yeah, happy to. We have a question from Samir, which is, can you please share with us typical biochar properties that are required for enhanced performance in asphalt applications?
Look, the most important is to be very fine particles of biochar. And I told you I use biochar from plastic and biochar from timber. Biochar from plastic looks to be require to be a small amount if you compare with the timber to get the same properties of the biochar modified bitumen. And if it's dry, it's unlikely because it's porous and take a lot of moisture. It's the best. It's meant to be fine and dry.
Because as far as I know, 20% of moisture is quite a bit, and it's good for transportation, but it actually does not come out of the production like this. So it should be possible to use drier biochar in the production process, right?
Yeah, but it's not safe because the biochar and the electrostatic issues.
This is why.
Now, as maybe I comment on this, it's just a matter of reasonable taking care of the transportation issue. I mean, also activated carbon is transported all over Europe as a daily business, and it's totally dry. So it's just a matter. You can't transport it in big bags. That's for sure. But if you, for example, load it in normal powder silos, which can be hacked up by lorries, it shouldn't be a problem to also establish a safe way to transport dry biochar. Right?
Or the other things, if it's chemical treated on site, to have a system to like a spray with the chemical things to start to spray when you are make the biochar, then I think it's more easier to be used.
Exactly.
Okay, Hans-Jörg, do we have any more questions?
Yes, there's another one that just came in. So, would biochar used in asphalt be consistent to create a carbon sink and be used to obtain carbon removal credits?
Yeah.
Should we answer this?
Maybe Harald, that's for you.
I think it's for all of us. Well, if you want to create carbon sink credits with biochar applications, it's about the durability. So does the biochar stay a carbon, or does it stay a carbon sink over a certain amount of time? And you can say yes, if it's used in asphalt, it will stay as a fixed carbon for a very long period of time. In Europe, it is generally that if asphalt is worn out, it is recycled and reused as asphalt again, and this does not change the carbon content actually of it. So asphalt, it would be a conserving use of biochar. It's not oxidized, so it would certainly be possible to create, well, not only to create, but also to certify the carbon sink and hand out credits for that. Would be the same if you use it in concrete. It is very difficult to get it back out of the concrete, and you can also not burn it. So it is it's a very stable carbon sink actually. So
I do have a question regarding permitting and regulations. How would you describe the situation regarding the permitted use of biochar?
Look, here in Australia, it's hard to use biochar. Plus, each state has different environmental legislation, and at least in New South Wales, it's unlikely to be used soon, because even the recycled plastic cannot be used, only if will be some testing which is too expensive to be done by the asphalt business to use the plastic. In the other states allow you to use the plastic in the road, in the asphalt. Now we are trying to do in the Victoria to prepare a trial using the plastic encapsulate biochar in the trial on the asphalt on the road to see how it's going.
Mm-hmm. Yeah, so this will most likely be a challenge in Europe also, but I think we can be moving, even if the steps are small. We'll take those steps together, and this is also a nice an argument to get together as an industry. We've been talking before this presentation about the next generation of roads, and I've had this discussion with other people before, to make some type of intelligent roads, or not only improve the quality and the strength of the asphalt, but also other properties like electrical conductivity. Can you say something about that? What do you see as a perspective? Where could this lead to?
Look, from the FTR results which I get from the chemical treated biochar, you can see the biochar surface is changing using the treatment, chemical treatment, and in the asphalt it's my feeling it's the next generation can be used like a to rechargeable on the road, because what happened if the biochar and the ash and the bitumen can be has the electrical conductivity. Think about this one can be used then in time to accumulate the energy from solar energy, then to recharge the trucks, to recharge the bus or the car on the road.
You even think, oh, okay, so you would use solar energy.
Look, this is like a dream to see, the future, but the biochar has high potential, from electrical point of view. And I saw when you are using this recycled plastic with biochar and the oil, it's very easy to spray like a thin layer of asphalt. Which this one is working the same like in the mobile battery, like electrode on the mobile battery. Now to see how much biochar, how much electricity, how much maybe it's long way till there, but it's from my point it's a starting point which maybe some people starting to look to see how this biochar can be used in the new asphalt technology.
Oh, that's interesting, because also it's discussed, or it's already there are trials in batteries and supercapacitors. Maybe you can create a symbiosis of roads and supercapacitors or something, and use them actually for energy storing. That's about the idea. Okay.
Yeah. Already I contact some supercapacitor business here in Australia, which they are making supercap for truck industry, for car industry, and I'm in contact with them to do some trials using the biochar modified bitumen, and to check the conductivity and the life of the battery using the modified bitumen biochar.
Very interesting. I think there are some interesting subjects and topics coming up in the future. Yes, Hans-Jörg?
Yeah, we have one more comment in the chat, and one question. The comment from Frank is that biochar is made from organic matter, not from petrochemical plastics, and black carbon tires is not biochar. I think that's a fair comment. And I mean, the context of carbon removal credits obviously only applies to biochar, because storing petrochemical plastics into asphalt would obviously not make it eligible for carbon credits. Then we have a question from Brian asking, you mentioned to put the biochar into plastic pellets. Does the plastic melt when making asphalt?
Yes. You know what happened? The plastic starting to melt and disperse in the bitumen, and the biochar, which already it's inside and chemical treated, it's acting like a extender for bitumen. The plastic improve the small improvement regarding the flexibility of the bitumen, and the biochar working like extender and like a stiffness. Actually, in the bitumen, the biochar acting like asphalted. The bitumen it's made from asphaltine maltase and the resin. When the the viscosity of the bitumen increase. It means the number of the asphalt in the mix is high. And the biochar acting like asphaltene increase the viscosity of the bitumen.
Mm-hmm.
And regarding the plastic, is not the biochar is not coming from plastic. Look, this one was the supplier from plastic. He told me it's biochar. From plastic, he's doing the biofuel and remain the powder, black powder today. Which that black powder I use the same way like a biochar from timber. I didn't have an opportunity to use the biochar from the other organic mass, but this is the. I'm not expert in the biochar how to make and what.
Yeah, it's sometimes it's very difficult to tell from the end products you receive if it's from which source it's coming, because actually after pyrolysis it's not organic anymore. It's just fixed carbon. So I think from your standpoint, you want to increase the properties or change the properties of the asphalt. It's less important what the source was. It's about the end product. And in biochar, it's a lot. There's quite a bit of a discussion of the sourcing. What is still considered biochar, if it was biological or if it was from fossil carbon. But I think in this regard, you know, with regards to carbon certificates, zinc certificates, that is quite important, because if you took something out of the underground of some fossil resources and used those, of course, if you store them afterwards, you cannot claim carbon credits for this. This is an important point. So of course, the carbon credits you could only claim on the organic part of your input materials. That's no doubt. Yeah. Yes. So. Are there more questions?
So not in the chat for now.
Okay. So thanks,
maybe
Alex.
While everybody is thinking about further questions, that's the right time to present the result of the questionnaire. So I'm gonna share my screen.
Did people participate?
You can see my screen now, and we can see here we got in total 10 answers, and yeah, most people had no knowledge to only some basic idea. The interest was mostly business driven, and on the applications, building materials and asphalt are the two winners in this. Well, that might not be representative, because people who are joining the webinar are obviously more interested and more driven by the vision that biochar can go into asphalt, bitumen, and building materials. So, but still very interesting. Thanks a lot to all those of you who have joined the questionnaire. And sorry if not all of you had the opportunity to go into it. Okay, so I'm gonna stop that here.
Thanks a lot. Yes, it is interesting because in many discussions, if you start talking about biochar, it's the agricultural uses, and people rather neglect the other types of uses that will be more important in the near future. And this is why we're so thankful for the work people like you are doing, Alex, to get us onto a path where we can actually use it in a profitable way, and not only as a substitute in order to store carbon, but really to have a superior product at one point that could just outcompete conventional products. And so to create long-lasting carbon sinks through an improvement of products. That's actually the aim we have. So thanks a lot for your work and for presenting it here in our EBI webinar. Thanks a lot. I will share the presentation if you give it to me with the people, and I will upload the webinar also online, so it will be you will be able to review also the graphs and some of the information we have heard now, because it was quite intense and some people have joined not really right at the beginning, so you might have missed a couple of key points. Thanks a lot.
Ahara, two more questions. Two more questions, respectively. Comments from Brian. How many field trials have been made? How many hours on real road? Alex, were you able to hear the question?
Look, in Australia, I told you we didn't make any trial. Now we organize in Victoria to see if we go ahead with Council Road to see how behave, to make a trial using the one section with no biochar, one section with the biochar in the mix, and the other one with plastic encapsulated biochar to see how it's working. Then we'll keep on to monitor in 1 year, 2 years time to see how it behave and how it's working, the biochar and the asphalt.
And then we have one additional question, which is related to the sourcing of the material. Is biochar from agro waste ideal for bitumen?
Look, to be honest, I think any biochar can be used in the bitumen or in the asphalt. Think about you burn everything, you don't have anything chemical remain on the surface of the final product, and I don't think it's any issue with any type of the biochar to be used. Only one thing I think depends the particles and the structure of the surface of the biochar play a role in the amount of the biochar required to be mixed, to be added in the bitumen to get the hard bitumen, stiff bitumen. But this one is only if you are doing some testing in the lab to see how it's working, then I think then it can be used.
Okay, I have 2 hands raised. Well, so we're not at the at the end, but it's good that there is a great interest. The first one was, I think, Marcel Huber. Yes. Do you want to unmute yourself?
Yeah. Thanks. As far as we have realized in our first tests here in Austria is that they really got into tar tracement. So I think it is important to note or state that at least in Europe, tar from biomass resources is absolutely banned from being attached to bitumen or to asphalt. So the first thing they analyzed was polyaromatic hydrocarbon, so it was quite funny. So don't think you get rid of your contaminated biochar in asphalt, because I think at least in Europe this is the total absolute no-go. And what we also got in information is that they do not like volatiles because of they get released in the plant end. But maybe that's the same with the dust. So the dust becomes an issue in mixing, and might be a big issue in real processing, big scale processing.
Yeah, because you have a dust, you have the fine particles which can be on the breathing of the people who is working, can go on the lung and have an issue with the healthy.
Well, in any case, if you use it in Europe and we have something to say about it, you will not dump your basically your toxic waste into asphalt. If it's biochar, it should be certified in some ways, and we're pushing for the EVC to be the standard basically. And if you use the basic material of the EBC, still it's you're on the safe side. You should be. Maybe we find some people to do some tests in the EU, as we seem to be quite quick. If we find the right actors to implement something on real roads to have it tested there. So hands up, or just contact us afterwards if you would be interested, and then we might get in contact. There's another hand raised of Hussein Jafari. Do you want to unmute yourself?
Yeah. Thanks, Harold. Alex, just another quick question. How do you see if the quality of the biochar supply changes, how does that affect the end product? Because you mentioned this biochar will act as both a modifier and an extender. So with the modification aspect of it, the quality might affect the rheological properties of the bitumen. Is that something that you are confident?
Yeah. Thank you for the question. The way I'm doing, first I'm using a batch of the biochar in the lab to set up the bitumen, to correlate all the bitumen with the biochar, to analyze how much biochar, that type of biochar required for the bitumen. Then based on the properties of the bitumen, how much and what quality of the biochar to be modified. Then we are doing the idea to go on the production. Doesn't make any sense to go straight in the production if you change, because I told you the biochar which we suppose come from plastic behave different in the bitumen than the biochar come from timber.
Thank you.
So before stopping it now, I will ask first, Hans-Jörg. Any more?
No further question here in the chat.
Okay, so I already thank you, Alex. I will thank you again because it's worth it. Thanks for everything. We stay in contact, and I'm sure there will be some more questions following this presentation of yours. So I'll just put you in contact with the respective people.
Thank you, Harold. Thank you for everyone for your time, and I hope we'll get some new products soon.
Thanks. And thanks for everybody. Thanks everybody for joining us here. Hope to see you at the next webinar, because it will continue with very interesting topics. Thanks a lot.
Thank you.
Thank you.
Thanks also from my side. Great job. Thank you.
Thanks. Take care. Bye.